Hello and welcome to another session about me learning Kyma. Well, in the last weeks we played around with Kyma a bit, we deployed some applications, but we mainly used the, let's say, Kubernetes layer underneath in order to do so. Now today we want to dive a bit more into the Kyma magic. And one very important area of Kyma, or the intention of Kyma, is to, well, extend applications, right? So that's kind of the core idea how Kyma was built in order to make extensions as easy as possible. And well, one central component in order to extend applications is something that was built by the Kyma team, and that's the application connector. I switched now to the documentation of the Kyma project in the area of the application connector as a component of Kyma. And within the application connector, you see an overview of the application connector. So it's consisting of several subcomponents in order to connect your external solution to your Kyma cluster. So there is, again, for incoming events that are brought to you by the solution, by the external solution, the Istio gateway that we already know. And then there are some other components that do all the heavy lifting around connectivity, checking certificates and so on and so forth, building a registry so that you can check which applications are available and so on and so forth. And the core thing that we will probably see today is around this application thingy. So that's what we see in front of us. All the other stuff is kind of used behind the curtains. So of course we use the application gateway in order to connect to an API. We use the Kubernetes secret store in order to make this a safe connection. And we have an application broker that brokers all the services that are exposed by the Commerce solution in order to make them usable in our application. So the documentation within Kyma is super extensive. It's clearly describing which subcomponent is responsible for what tasks. So we have a connector service that handles all this, as I mentioned before, certificate handling. We have the registry, which registers your APIs. We have the eventing service, the application per se, which is kind of a, let's say, container of an external solution connected to Kyma. So it handles all the integration topics. And what we will see is this open service broker implementation that is done by the Kyma team, and that is represented by the application broker. This is something which we will need in order to connect to the application. As you remember from the previous sessions, we had this service catalog, and we had all the things connected to it with the service instances and the open service broker that I mentioned there. And this is now one use case where this comes into play. Yeah, and there's a lot of other things that go along with this application connector thingy. Okay, so let's dive into the code. Let's dive into the things that we can explore. Now, I do not have access to an external system like a Commerce Cloud or Marketing Cloud or C4C. So I think you too have to come around this. And there are two really cool blogs out there by Jamie Cawley that guide you through setting up a mock for these applications. So you do not need to have access to a Commerce Cloud system. You can mock it, and the source code in order to mock it is publicly available on GitHub. So basically, we will now walk through this blog, as well as to another one where the mock is connected to a function within Kyma. So we will now also use one area that is kind of a unique selling point of Kyma, namely the function area, where you can hook up very lightweight code pieces called functions that are brought to you via a function as a service offering with Knative underneath to an application and react on events and do things there. Okay, so yeah, let's walk through it. So we have this GitHub repo here where these mocked applications are lying in there. Now, before we go into the system, let's dive a bit into the GitHub repo. So here we have the GitHub repo. There is some description around the installation for the different mock types. And there is also a description how to go there. So we will basically use the commerce mock, which is kind of the most extensive mock available. So there is a C4C in the marketing mock, but there aren't that many services in there. So let's go into the commerce mock. And the commerce mock emulates the SAP Commerce Cloud as expected, and it uses the Varkas API server. Okay, so okay, this is also called Varkas config, so this probably has something to do with that. Now, what is Varkas? Now, Varkas is another tool that was developed by the Kyma inventors, Kyma developers, in order to deal with mocking up things. And I opened up the GitHub repo here. So let's see if I have, well, I can zoom in a bit more, I guess. This is 150 now, yeah. Okay, so now you should really be able to see it. Let me cross-check it. Yeah. So Varkas is another project by the Kyma team. It's in the Kyma incubator area, so it's not really released, as you also can see from the version number. There have been some updates recently, as I'm recording that one, but it seems to be quite stable. And this Varkas gives you all the things that you need in order to mock up an application. So you have an API server that serves an API to pair with the Kyma cluster. So this is kind of the connection point. We have the app connector, which is one important component because this is the thing that does all the communication between the Kyma cluster and your application, or your mocked application in this case. Then we have a cockpit, which allows you to have an overview about the API server, and then you can mock open APIs or OData services, and you can configure that. And from an architectural perspective, that's quite near the thing that we saw before when we took a look at the application connector. It's a little bit, well, slimmed down. Because here we have the API server that serves the APIs, that does the pairing with the application on Kyma side, which does the registration and so on and so forth. And this API server also allows you to send events. And on the other side, Kyma can, if you have a service instance running, call an API that is mocked and served by workers. So that's really cool. So you do not only get by Kyma the infrastructure to create extensions, but you also get for free all the infrastructure in order to mock applications and to run them and to hook them up into your Kyma cluster. So that's really, really cool. So what's in there? So I guess we can take a look at the app.js. So what we have here is, well, we do hook in several stuff from workers, all the stuff that I mentioned. So the mocks and so on and so forth. We have an Express app here. And we fetch some information about orders. Okay. So then there is some running. There we do a customization of the mocks with the app, with the Express app. So we do the configuration via this config JSON file. Okay. And we set up all the different components of workers and make them accessible to the Express app. Okay. Well, this Express app is then set up as usual, and we have some customization of the mock with respect to very specific calls. This seems to be an API call to orders and to users, where there is some specific return of a total price with text. Okay, so if we make a call to that endpoint with a specific, it seems, order code, is this right? Let's see. So app-get, yeah, an order is returned. Okay, so that's kind of the core. Then we have the configuration, what's in there. We say we have an application that's called SAP Commerce Cloud. Okay. And we have an event that's represented within the folder APIs events.yaml. We have several APIs. We can specify the authentication. Okay. We can also give in there a description. Okay. So the rest of the magic basically is then here within the APIs, right? So we have some EDMX files, which is then something for the OData calls. We have an events.yaml file. Okay. And we have several other YAML files that are basically REST services, I would get. So let's see at the events. We have an async API specification. Okay. And here is a description of the events that are emitted. So we have a customer created, we have a order placed with a specific payload and some properties with some example values that we can also do there. Okay, that's for the events that can be raised. Now let's take a look at the, let's say, I don't know, what should we take? Not an EDMX file. Let's take a look at the permissions.yaml. So this is now a Swagger file, okay, which is a REST type. And we have several paths there. We have the HTTP verbs and the parameters. Okay, so we can basically use all the open specifications, OData, Swagger, or OpenAPI, how it's called, or async API for events. And this will then be fetched by the workers configuration. So this tells the system where to find the APIs. This is the content of the APIs. And the app serves it. Okay, then we also have this orders.json. What's in there? Okay, that's just the a description of all the orders that are there that I think was called in the app.json, right? Yeah, this is that one, I would guess. Okay. Okay. So basically this already gives us quite some stuff. We can also run it locally. We won't do that. Okay. So everything is here. Now we have a deployment file. So because we want to deploy it to Kyma, we need something like that. Let's see what we have in there. So nothing new from for the experts that we are now, as we have seen quite some YAML files, at least 4 of them. No, just kidding. So we have a commerce mock, okay. We have some strategy about the updates. We have one replica of the commerce mock, and the container is fetched from Google Cloud registry of the Kyma project, okay. We have some port exposed. We have several environment variables here concerning debugging and renewing certs, okay. And then we have a volume mount. We didn't come across that up to now. Let's see what that means. We have some resource limitations, okay. And here we have a volume that's called commerce mock volume and a persistent volume claim that's commerce mock. That's new, that we didn't come across that up to now. We have a service, that's the service that we want to expose, that's correct. And then we have a persistent volume claim. Okay, so we probably claim a persistent volume within the Kyma cluster with some access mode and some storage requirement. Okay, so now what's behind that volume part here, because we did not use that up to now in the session. So because I prepared the sessions, I looked that up before, and volumes basically deal with the point that your containers are, and I do not even try to pronounce that word, ephemeral, so which means that if you have data stored within your container and the container crashes, the data is lost. So now what you want to do with that issue is, or what Kubernetes does is that you can mount volumes within your container, which is an external data storage that will not be lost when your container crashes. So that's basically what's behind this term volume. Now the persistent volume is basically an API that allows you to, as a user or as an administrator of your Kubernetes cluster, to access storage. And so we have the volume, which is a persistency outside of your container. So it's really persistent. It's not lost when your container gets lost. We have an abstraction layer above the volume, because we do not want to deal with any specifics of the volume of the storage that is attached. I do not care how that is handled. And we have a persistent volume claim. That is a request for storage by a user, and that's exactly what's in here. We have this persistent volume claim, and so we want to claim that. We want to tell the Kubernetes cluster, hey, I need that volume. So that's new. The rest I think is well known. Okay. I think that should be fine for now. So let's do it. So what do we have to do? We have to create a namespace, and this is what we will do. So we will create the namespace. We call it mock commerce, because we will mock up commerce, a commerce system. We do not apply any labels. We do just create the mock commerce space. Okay. Now, as we want later on to also hook up some serverless functions, I will now also create another namespace. Because I do not want to put that function that I want to hook up to my commerce into that mock commerce namespace. So let's add serverless commerce to the namespaces. So we create that one too. So now we have two namespaces, one in order to put our mocked commerce application in, and one that will serve for our functions. So this is now completely empty, so we have no deployments in there. That's fine. So let's switch back. Of course, we need to update our kubeconfig. I already did that. And then we do an application of the YAML. So let's switch to that one here. I will make that larger. Let's see. So we have kubectl -n mock commerce. Apply. We'll just check if it's large enough. Yeah, I can go one further. And then we apply the file from the commerce application where we now deploy the deployment per se, the service that we want to expose, and the persistent volume claim for the commerce mock. So let's see. This should now also be running. So it's initializing. It's setting up all the things that we need. Let's refresh it. Yeah, that's as usual first an error because it has to fetch the image, has to download it, and has to do the deployment. That takes a bit of a time in order to do it. So let's switch back to the blog. We also need to deploy the xf YAML file. Okay, so that's then the other one. What do we have here? Oh, it's basically just an API rule that says for the commerce mock app, please expose. We do just support get, post, put, delete, and head, so no patch, and we have no op. Okay, so I will put that one up in the cockpit as soon as we are up. So we have no restarts, the pods are running, the replica set is up, the commerce mock is up, the service is up and running, so we have no API rule. I will expose that one. We call it commerce mock to stay consistent. We do not support patch. We have that one. Okay. So let's create it. Now again, I think the mock application is quite something to start up. So let's see if we can already connect to it. No, we can not, because it's not up and running yet, really. So let's just wait a bit until it starts up. Okay. So that's fine. So we have now all the applications there. The next thing that he does is opening the application. Well, as we can read here, this will take a few minutes in order to start up everything to get things running. So we cannot yet go to that page, but that's okay. Very nice sentence. If an error is returned, wait a few minutes and try again. That's always a good approach within Kyma if you have large deployments. So don't expect it to be up and running within a second. So just have a bit of patience. But at some point in time, it should be there. Now, what do we have to do next? We have now our mock application. This is just a Kubernetes deployment. It's just mocking an application. We have exposed the application, or to be more precise, all the nice and nitty things that Varkas gives us via the API rule. But now, as we are within the SAP Cloud Platform, within the trial environment, we have to hook things up. So we have to bring all the things together, and in order to do so, we have to connect all the systems together. Now, this is done within the SAP Cloud Platform cockpit. So what we first have to do is we have to make the SAP Cloud Platform on global level aware that there is a system that it has to pair. And this is where this application connector thing comes into play. So we will then use the application connector, hand over a token. So it's basically really a one-click pairing, and all the rest of exchanging certificates and so on and so forth is done behind the scenes. At least that's my understanding. So let's go to the trial. So I have to enlarge that a bit, and let's go to our global area. Of course, the browser session expired as usual. Okay, so now we are on the global account level, and here we have an area that's called System Landscape, and this is where you can define two things, or where you can do actions on two things. The first one is register systems, and the second one is building formations. I will say something about that later on. Now, the register systems area is where you do the pairing. Now, there is one thing that I learned. help.sap.com is not the best source when you look for something. So I looked for System Landscape and systems within the help.sap.com area, having navigated to the SAP Cloud Platform area, and all I got was news about or help about setting up HANA. I don't know why. So there is some section about that, so I can show you. That tells you how to register an SAP system. So there are only some SAP systems supported right now. So this one-click thingy, which is S/4HANA Cloud, which is SuccessFactors. They are both available for Cloud Foundry and Kyma. And we have Commerce Cloud, Cloud for Customer, and Field Service Management, which is available for Kyma only. Which is not really surprising, as Kyma comes from the area of commerce. So this is quite clear. Unfortunately, no S/4HANA on-prem, so you have to do the more manual approach. And well, basically, you can do the registration there. Now there is one sentence that's important to think about when you deal with Kyma. So you can have you have some default limit with respect to total connected systems and namespaces, which is defaulted to 10. So you can have 2 namespaces and 5 connected systems, summed up, not multiplied, summed up. So you can have 5 systems and 5 namespaces, or 8 systems and 2 namespaces, and so on and so forth. So any combination that sums up to 10 lets you run into that limit, but you can put in a support ticket to raise the quota to 20. As you can also see here, if you are in the area of Microsoft Azure, so I'm not an AWS guy, but within Azure, you also run into some limitations, especially when it comes to virtual machines. Then you raise a ticket, and basically within a minute it's done because it's automated. This doesn't look as automated here if I read that sentence correctly. So yeah, nevertheless, there is some help about that, but you will not find it. But how did I find it? Well, there is one thing that is really useful within SAP Cloud Platform Cockpit, and that's the help button, which then gives you some context-sensitive help. And in the no, I didn't want to do that. And in the best case, there is also a link to help.sap.com somewhere hidden in between. So you can then navigate to there. But this help is already quite nice. Tells you what to do. For example, here, depending on the system type, you can view the integration token, generate a new value integrated token. So that's only value right. So if the status of the registration process is pending, if it's paired, it's paired. I did not find any way to get rid of a registered system, to be honest. So I have a question open on the SAP community on that. Now let's register a system. How did Jamie call it? Let's call it commerce mock. Let's stay consistent. Which is a Commerce Cloud system. So we really use Commerce Cloud because we perfectly mock that, or Varcast does that job for us, and we register it. Now what we get is a token, and thankfully a copy to clipboard button where we copy that token and we close it. And as you see, the status is pending. We can do a display of the token because the handshake is not yet done. So let's see if we can do the handshake now. We should now be able to navigate to the SAP Commerce Cloud mock, and as you can see, we are now in the cockpit that Varcast gave us, that represents all the APIs that are available. So as you can see, we have the events based on the async API, we have OData services, we have some Swagger REST APIs. This is now just locally available because we did not yet connect the stuff. So also now we will now connect it. We will copy the token that we have received from SAP Cloud Platform here. This checkbox, from my understanding, is relevant if you have no certificate authorization to connect to Kyma, but that's not the case here. So we can simply connect it. And what happens now is we have the status connected. We have not yet assigned an application or a cluster. We will do them in a second. And we can register APIs that are currently local in order to expose them remotely. So currently we have no remote API, so it's just an application that's connected to the SAP Cloud Platform. Now let's move on. This should now be registered. Exactly. So now also the action button has vanished. Usually there is URL to the system, but as we are mocking up something, I think this wouldn't be filled. That's fine. We have our Commerce Cloud system registered, and now we have to go one step further, which from my perspective makes perfect sense. It's really something that is valuable, and that's about formations. So we now have to define a formation. Up to now, we just have linked the two systems together. And now we have to make these linked or a connected paired system available to our SAP account. And what's the idea behind that? So I also looked that up in the help.sap.com area. Where I think, is this here? No, this is just registering. Oh, I did not paste the link here. Let's see if I'm fast and I can find it. Yeah, it's here. Oh, it was too easy. Well, we have registered the SAP system. Now we have to assign it to information. And the idea behind it is to create kind of a bucket of SAP systems, of probably different SAP solution that belong to one business context or one business case. And you want to create a formation you make to make all those systems available to one sub account, to one specific application, in order to build extensions on top of that. And I think that's really something useful, because that allows you as an administrator already to maybe exclude systems because you do not want to have them in there, and build really a clear bucket of systems based on the business case in order to extend your system. So that's quite cool from my perspective. That's really a feature that I like. So let's create a formation. So we call we call that again commerce mock. We select that sub account, so we link it up to the trial sub account, and then we select systems. And as you can see here, you can, if you have several systems up, you can select several systems there. We have just a commerce mock, and now we can create it. So here we have now a formation called commerce mock. We assigned that to the trial sub account. Due to the fact that we have registered the system, we can assign that to a formation. We have several actions like edit. We cannot delete it because it's assigned to a system and it's assigned to a sub account. Now the funny thing is, I can remove the selected system. I cannot remove the sub account. So like for the system pairing, I will never get rid of the formation as far as I understand it. I also have an open question on that one on the SAP community. I will keep you updated what comes out, because I do not get it, because usually you should also be able as an administrator to get rid of formations. Why not? In a development system, that's basically will happen quite often, but yeah, no idea why that's not possible. Okay, so what have we done? We have brought up the commerce mock, which is up and running. We have registered the commerce mock in the SAP Cloud Platform cockpit as a system, which allows us on the other side to expose APIs now from the commerce mock. We have built a formation, so we have assigned the commerce mock to the trial sub account. So we can now hook all the things up, and that's basically what we will do. So let's see what the blog says to do next. Where was it? Here we have token. We have put in the token. Yeah, fine. We have created the formation, and now we can register all the APIs. We can also register just a sub amount of those APIs for external usage. So we will now really register all of them. So we are here. So here this info button shows you the progress. So let's register all. And now this shows you, okay, we are now bit by bit registering the APIs, the events, the OData services, and well, it's in progress. So I think it's 24 APIs, events that need to be registered. So this also takes a bit of a time, and as soon as they are registered, they are also showing up here. And now you can also remove them from here. So if you made an error by well, registering one service too much, you can deregister it, but you have to do that on the remote API section. So yeah, I think that's it. So we have the formation, we have that. We go back to the namespace, and now we can see within the integration area that we have the application MP Commerce mock, because we have made this pairing, we have made the formation, it's serving, and we now have all the services and events that are provided. They are shown here. So we have APIs, we have events, mostly our APIs, and we hopefully have somewhere in between an event. Maybe that's not refreshed properly. Yeah, here we go. There is the event. Okay, what we do not yet have is a namespace binding. So we are kind of in the cockpit of Kyma, in the dashboard, where we have all the namespaces available, but we have no application, and this is where the thing kicks in that I showed you before. Let's switch to that one. We have no application registered up to now. So we're just, I wouldn't say app use Kyma, but we're using Kyma in order to serve the mock. We have paired everything up, so all the thing is available within the Kyma cluster, but we have not yet linked the application to a namespace, so there is no application brokering going on. So let's quickly check what happened within the mock commerce space with respect to things that have been created in the background. So we have created the API rules. That's fine. The config maps did not change. I don't think that there are any resources there yet. So everything's fine there. We have no new services there. It's all the 25 services and the 3 from the hyperscalers. So let's see by operations. So we have the one deployment, we have the replica set, we have the pod, we have the service that is up and running, and we have some secrets there with respect to issue and so on and so forth. So nothing really heavily changed there. Within the serverless commerce space, we did not do anything. So what will we do next now is we bind that to a namespace in order to make it available. So let's go for the serverless commerce namespace. Now I can either make all the services or events available, or I can make a subset of them available. So for example, I can say I want to have events, I want to have I don't know, commerce web services, and the order management. So that's possible. So I can restrict my extension story in several steps. So I start pairing the system, which makes the system available within the SAP Cloud Platform. Then I go one step down and I make these formations, which give you an overall story of the business scenario that you want to extend and the systems that are there. Then from the serving system, or from the side of the house of the serving system, which was in our case the commerce mock, I can expose APIs, I can expose events by registering them, but I do not need to expose all of them. So I can also do a little, let's say, restriction of the services that are available that I think make sense in order to build extensions on that. And then within the Kyma dashboard, I can further restrict the available APIs with respect to my very specific scenario, with respect to a namespace by doing the binding. Okay, so let's create that. So we have 3 services out of 24 bind to the serverless commerce namespace. Now, as we can see, we have now 1 bound application within this namespace. So what happened here? Let's take a look at the service management. So now we have 1 additional service available, and that's the one that we hooked up. It is this commerce mock thingy that we created, and that's available now within the service catalog. Now, if you remember one of the, I think the very first sessions, we talked about the catalog and the instances, and it's like, let's say if you go to the restaurant, this is kind of the menu that you have. These are all the dishes that you can order. And if you order something, then that's the instance. So that's the concrete instantiation of a service. So we have now those 3 there that we can instantiate. Now let's see if something else was created here. So nothing more here. But here we have, that's what I was looking for. Of course, it's in the service management. That's the application broker. That's the one that I mentioned before. That was given, I think, here. The application broker that serves as an implementation of the Open Service Broker API in order to make the APIs accessible within the Kyma cluster. So that's also something that comes with Kyma, which is an added value that Kyma provides to you. Yeah, so let's see. We have now all the stuff available, so we can build an extension now. So why don't we do that with a serverless extension? And that's within this next part of the blog of Jamie. Why didn't I like them? Something that just struck my mind. Because they're really good. Okay, so yeah. Yeah, that's basically what we have to do now. We have to create a service instance in order to have the information available within our system. So yeah, we create the service instance, and what does he do? He creates a service instance for the events. He creates and he creates an instance of the web services. That's nice. So basically, I would guess that, and I know it because I already read it, that we will, as the end goal, create a function within Kyma, which is triggered by the event, then uses the API to fetch some additional information from the commerce mock area, and do something with the information, and then I think it's a console.log that happens here. I mean, it's just a showcase, but it shows you how to do things basically. Now, what's the point? I think this is a blueprint of an extension architecture when it comes to event-driven extensions. Why? We want to do a loose coupling with the system that we want to extend. So this system will just raise an event. due to this event, I will react. So let's say this is, we will use here the order created event. So an order was created, so I can react on this event. Now, whatever I want to do, the system that raises the event does not care about it all. It just says, hey, I have an order created. Here is the order number. Do whatever you want to do. If you want to do nothing, I'm fine. If you want to do something, I'm fine too. So as a pattern within this kind of extension, you get the event, and then you basically have to do additional API calls to gather all the information to do your extension, because the event does not contain that information. The payload of an event typically is very slim. It just contains the topic, and it tells you or gives you the basic information depending on the context what happened. So in this case, it was the order created context. It does not contain a big payload about the order number, when the order was done, who had done the order, what was part of the order, what was the payment method for the order, and so on and so forth. That's not the idea behind events. Events are very slim. If you want to have that, you need messages. So messages usually have a bigger payload. They contain much more information. They are really like a message, like a message in the sense of a letter or an email that you write, where you have a subject, where you have a body, where you have content, where you have a lot of content that you can use. That's not the idea behind events. That's the idea behind messages. But we want to have event driven. So this is a very typical pattern. You have the event, you get the basic information, you fetch the information, and then you call additional APIs. And that's then where the formation area comes into play. Because the order create event, the system does not even know what you want to do, and it doesn't need to know that. It just gives you the event, and you then orchestrate all the subsequent calls. That's it. Very, very usual pattern, and very powerful pattern from my perspective. Something that we have to wrap our mind around, because in the past, I think extensions have been developed differently, and the coupling was not that loose. So yeah, let's go. Let's go into the catalog. So what we need is we need the events. So we add an instance. They have really cute names there. I will leave them because I like them. It's Minty Remote. So let's do that. As you can see, it's provisioning and it's already running. So the instance was provisioned successfully. So you can see we have now all the information here, like the order created information, which has a super slim, that's a perfect example for a event. Super slim payload, it's just the order code. And that's all you need, because that's what's relevant when the order is created. Here now you have a service instance not bindable. That's right, because it's an event. So we cannot bind an event in the sense that we can call it as an API. That's perfectly fine for events. Next, we need the Commerce Web Service, if I remember correctly. Event, the Commerce Web Service, here we go, yeah, I was right. So here we have several services. Oops. We add that one. Horrible engineer. What fits better? Then we create it. It's running, so it's super fast. So here we have the same section as before. We have the API with all the description of the API based on the open API specification. And here we have this section that was missing before, so we can now bind applications and yeah, also get some highlighting with respect to the information around the binding. Okay, we have not bound any application there because we have to develop it. So let's see if something happened here, and quite a lot happened here. If you remember, before we had all fitting on one page, so there quite some things came along. As you can see, Because we have registered the event, we have some event brokering on the ingress area, so on the networking area. We have some filtering in there for the topics. We have the same on the Istio level, so on the service mesh level. So this is all the secrets that have been created. Also on the gateway level. What else do we have? Yeah, also the token stuff. There, it's all still within the areas of Kubernetes, of Helm, and of Istio. So nothing special there. And we have some more services that have been created in the behind the scenes, because we have created those instances. Makes perfect sense. And there is now also these Knative thingies come into play. So Knative is also part of Kyma. It's kind of an abstraction layer that lies on top of Kubernetes, which makes your life easier with respect to definition of resources. So it adds some resources, and it focuses on event-driven, let's say event-driven applications, and brings some custom-defined resources in that area. I will not dive into depth within this session now into Knative. I will do that in a subsequent session where we will also see what additional resource types come into play with Knative. Okay, so quite some stuff is going on here. We have now several additional pods running with some restarts, but they're running. That's fine. We have now some replica sets that came up with respect to this brokering of the information. And of course, if we have replica sets, we also have a complete deployment on that area. So just by creating those two instances, quite some stuff happened here behind the scenes that you do not have to care about. So that's all done by Kyma, and that's really great. So now we switch into the area that you might have been longing for. That's the function area. So we already had some insight into function as a service when I deployed Azure Functions on Kyma. But there is now also a built-in function area that's completely based on Knative. So you really implement your functions in there. And yeah, we will see in a second that there are some similarities with like something like Azure Functions, or I also guess AWS Lambda. And there are some things that have room for improvement. So let's move on. We have it here. Now we will create a function. So in order to create the function, we will create the function. We will add an event trigger in order to consume the order created event. And then we will create a service binding to this web service where we fetch additional information for the order. So let's do that. Let's create a function. Let's call it order created func. We can add labels there, but there's no need to do that. So we create that. And as soon as we create it, we get some basic skeleton. It's building things up. We have a logging area here hidden below. We have the source code. We have environmental variables. And in addition, on the besides the code level, we have a configuration level. So within the configuration level, we have some basic configuration around the minimum replicas, the maximum replicas. We will dive a bit deeper into that next time when we do the Knative more deep dive thingy. We have some predefined requests and limits. Of course, we can edit that configuration and increase, decrease everything here. We will not do that now. We have API rules, so we can expose the function to the outside. So we can make it callable from the outside. And here we have the things that we want to go into. So we can add an event trigger. We go for the order. Let's see, order dot created. Yeah. This is how a help should work. Simply help you. Okay, we put that one in. And as we have written in the blog, we create a service binding. So we need the service instance to the horrible engineer. We can select a prefix. We can create new secrets or use existing one. We leave the we leave the settings. I think this is really helpful if you bind to several service instances to give a prefix for the variable. Because then this allows you a grouping of the variables of the service bindings of the injected variables depending on the service instance. I think that's really also a nice feature that helps you a lot. So we create that one. As you can see, there are now several environment variables injected due to the service binding into the function. So we have the target URL, the gateway URL, we have the credential type and the basic configuration of the instance. That's simply given due to the fact that it's standardized open source broker instance. So we have hooked everything up here, which also means that we can now see, just as a cross check, if we go for horrible engineer, we have now one bound application. That we see here, status is ready, credentials are ready. Okay, so let's switch back to the function. We have all the environment variables now here. Now what do we want to do? We want to consume the event, and then we want to call an API and fetch some additional data and do a console log. Now, this is where I think there is a lot of room for improvement. This is now at the moment the only way, besides of an editor, an IE, Visual Studio Code, VI whatsoever, to create your source code. You have some kind of syntax highlighting, but if you think about the way that you might have had a glance within the last session on Azure Functions, and there is quite some room to improve in order to make the deployment and the creation of those functions easier with respect to the configuration, with respect to the code, and so on and so forth. Nevertheless, if you do something with functions in any area, you will see there are quite common patterns. So we have module exports, which is always there. We have a function that gets in the event explicitly and gets an overall context and processing context and can return something here. I did not yet dive too deep into the functions area for Knative. I will do that in a subsequent session. What I see here is basically that you can consume HTTP-based workloads and you can return HTTP-based workloads from the function, which is a bit different with respect, for example, to Azure Functions, where you can have very different bindings. So Azure Functions in combination with Kida. So that's definitely a difference. And we have dependencies. So we have some package.json file principally, where we can have the name, the version, and the dependency, which is then fetched from the npm registry, for example, which I think is somewhere here defined within the config maps. So here we have this Docker files Node.js that tell you how to implement it. And now we have also a config map for our order created function in order to have things here. Let's see if we can see something there. So we have all the information here about the function, like the config map, API version, and so on and so forth. So we will dive a bit deeper into that in one of the next sessions, I would guess. So now let's switch back. Let's do some coding, or let's copy some coding. So what we have here is we add a dependency, which is Axios, which is a library that allows you to do async API calls. It's kind of an established, I wouldn't say standard, but it's quite heavily used within the area of Node. So we saved that. So be aware, you have to save that here. You can now also do diffs, but I don't know what it's taken as a diff. So probably if I change it, I have to check that out now. So now we also put in some code. So let's put it in and then see what it does. Just replace that here. If I now do diff. Okay. It's if it's not safe, I can see what's the different what I did. Yeah, okay. Okay. Okay, we drag in the Axios dependency that we have defined there. We have a commerce URL that's taken from the environment variables, where I have to put in my service gateway service URL. That's basically that one. So let's put that one here. And then we have the main block, which is this function. It unwraps the event and fetches the order code from the event. Okay, that's fine. Then it does a call to the get order details function that we have defined here, which is an asynchronous function, with the order code handed over in order to get the result. And then it does a console log and console log the order result. And within the get order details, that's the pattern that I meant before. So you get the ID and you do something. We build up the order. So we do make use of this service binding, service instance binding. We issue a get request to the orders URL, wait for the response, return the response data, and log the response data. So let's save that. So it's in the background, it's rebuilding the container. It's redeploying the container. Yeah, now it's deploying. This takes, of course, a bit of a time. And then we can also open up here the logs. Yeah. So I think within the next session, we will also take a bit deeper look into that. Now we should also see a pod that's, yeah, here we have the function that's currently redeployed. Oh no, that one was terminated, that one is waiting. Okay. So this will now really take a bit of a time. Okay, this one says it's running. And this one says it's running. Yeah, fine. Everything's fine. So we have now the pod here. As you can see, there is quite some thing going on. There's quite some automated tagging done by the environment. So if we have now our function, we should now be able to trigger that function. How do we do that? If you are within the Cloud Commerce mock cockpit and switch to remote APIs, you can jump into one of the APIs, into one of the events, and you see the API details there, and you can then simply raise an event, which will then be consumed by the system. So let's put that stuff. No. Let's put that one here. Let's put that one out. So next time I will use fancy zones again in order to make that more feasible. So yeah, let's send the event. So the event was sent. And now hopefully, yeah, it fired. As you could see here, that was quite fast. The event was sent and it fired, so we exactly got this console log order result. We got the order ID, which was part of the order result I would guess, and then we get the total price with tax, where you, as we saw before, when we took a look at the Git repo, this was kind of this generic response if a specific route was hit. Yeah, and that was it. And also the information that is cancelable, so we can cancel the event. Yeah, so everything's working right out of the box successfully. That's really cool. Okay. Yeah, that was all that I basically wanted to show you today. So let's shortly recap, or let's see if we did not miss anything first. No, that was all. So what was today's session about? Today's session was focusing on extending an application using the Kyma environment, and really making use of the magic that is within Kyma, especially with respect to this application connector thingy. That allows you to bring together all the resources in a quite easy way. In order to do so, and as I think most of us do not have access to a cloud for customer system or a Commerce Cloud system, we used the XF application mocks that are provided by SAP in order to build a commerce mock within our Kyma runtime. We deployed that resource and then we made it available within the SAP Cloud Platform, making use of the system registration process, which shows you this application connector thingy also a bit, or this connector thingy in general with respect to token exchange. Then we built a formation where we made the app available to the registered system available to our SAP account. And then within Kyma, we also hooked up all the things together. We can take a look at that once again. No, not with that one. Once again here. No. Yeah. So we made that application systems available. We exposed the services and we made a namespace binding to our namespace. We restricted the service and events that we want to bind, so we are not forced to do everything, so we can funnel everything down. And then within this target namespace, we created, based on the service catalog, two instances of the services, one event and one API instance. And we then use the event in order to create a function and to trigger the function. And we use the service binding within the function in order to call the API from the function without having to care about anything. Because all the authentication stuff and so on and so forth, all the routing is done by Kyma. So as you saw, you just have to plug the things in the right way together, and then you can, I wouldn't say comfortably, but you can create then functions and create function-based extensions. And as we have also seen when we took a look at the secrets, when you took a look at the config maps, at the pods and the deployments that have been done for us within the Kyma runtime, I think that's really making your life much easier. Okay, so let's switch back here. So I hope you enjoyed this. Let's see, quite lengthy session about, well, the first real touch point with Kyma and its application. Yeah, and I hope you learned a lot, like me when preparing that session, like me when showing that session. And yeah, let's see what comes next. I would think we will dive a bit more into Knative. We will dive a bit more into the area of what Knative brings us along the road, and what is also covered from a complexity perspective by Kyma, by making use of the Kyma environment. Okay, so hope you enjoyed it, and see you next time. Bye.